Now we want to begin a discussion on surface area. And on this video, we're going to focus on prisms and cylinders. Now, first of all, a prism. A prism is a polyhedron. And it has this property, though. You've got a couple of its faces are parallel and congruent. Now, this one here, this first one we're looking at, it is a rectangular prism because notice the bases that are parallel and congruent are rectangles. Okay, so they're parallel. Now this is a right rectangular prism, and notice what makes it a right rectangular prism is the fact that these other faces make a right angle with the parallel bases, with these congruent parallel bases. Okay, so you've got this face up here and this face down here, and we call these bases. Okay, so the congruent parallel faces we call bases, and the other faces we call lateral faces. Okay, what makes it a right prism is that these lateral faces make right angles here at the intersection of the bases. Now, this also is a prism over here, but notice that these lateral faces don't make a right angle with the bases. Okay. Now, we've got the height, just like we do with the right rectangular prism over here. And of course, this is a triangular prism. Notice that the base here is triangular. We've got the height, and in the case of the oblique prism, it's not a right prism, it's an oblique one, we have a slant height. Okay, the distance up this face over here. Okay, so this is called the slant height. Now, if we want to talk about the surface area, really all you need to do is calculate the area of each face. So in this case, notice, for this one here, we've got 3 times 5. That's the bottom. The top is 3 times 5. Okay, and then we've got this face here, which is 8 times 5. Okay, and then we've got the one immediately across from it, which is 8 times 5. And then we've got these two, which is 3 times 8. Notice this is 3, this is 8. So we've got 3 times 8 plus 3 times 8. Yeah, like that. So notice that takes care of all the surface area, this right here. And this will always work. It's kind of cumbersome, though, having to add up all those things. So we would like maybe a formula for working through that. Well, let's go ahead and work this out. We've got 15 and 15, so there's 2 times 15. There's 40 and 40, so that's 2 times 40. And then 2 times 24. So we add up all of those and we get the surface area. Now, if we cut off the top, the bases, we refer to that as the lateral surface area. So in other words, if I take out this right here and just look at the area of these lateral faces, we call that the lateral surface area. But anyway, it would help if we had a little bit of maybe a formula that we could use. For example, in this case right here, notice that we want to get the surface area of this thing. This is definitely a prism. Well, think about this. What if we unravel this prism? So we take this, unravel it, and we get this thing. And we want to talk about the area of this. Okay, the surface area. Well, you can see what we would do is we have the base, we have the area of this base and the area of this base. So that's 2 times b. where capital B is the area of the base. And then we've got this rectangle here. Look at this, where we've got P times H. Okay. Well, that's going to be the surface area right there. And notice what P is. P is the perimeter. Okay. So if I add this up, the distance around here, and this is for a right prism. Okay. This is for a right prism. Notice I unravel it, and I take the area of the base, double it, and then take the perimeter times the height. So we could have done that here with this previous problem. Notice I take the area of the base, which is 15. So I've got 2 times 15. And then I take the perimeter, okay, which is 5 and 5, that's 10, 3 and 3 is 6, plus, okay, so that's 16. See, the perimeter of this base times the height. Okay. And let's see what we get. We get 158. Now, if we didn't work through this, but let's see what we get. We get 30 plus 80 plus 48. And let's see what that is. If we add that up, then we get, you guessed it, 158. See, we get the same thing. So what we have is, we have this formula that we can use for the surface area of a right prism. Okay, it has to be a right prism. Okay, so let's see how this would work for this part A here. We've got 2 times 50, right? Okay, that's the area of the base, plus the height times the perimeter of the base. Well, the perimeter of the base is 30. Okay, so notice it's 2b plus the height times the perimeter times the height. Okay. Yeah. So if we work this out, we would get 100 plus 180. So that's going to be 280. Now we could do the same thing for part B. This is a triangular prism. And notice that we want to talk about the area of the triangle. Now, this is an equilateral triangle. So remember, we have a formula for the equilateral triangle that we can use. So for the equilateral triangle, we're going to have the base as 1/4 square root of 3 times the sides squared. Okay, so we'll utilize that here. The alternative is we could do 1/2 base times height, but then we have to find the height. So here's what we've got. We've got the base is equal to 1/4 square root of 3 times 7 squared. Well, that's going to be 49/4 times the square root of 3. There are 2 of those. Okay, 2 of these 49/4 square root of 3 plus the perimeter, which is 21 times the height. Yeah. So here we've got 49 over 2 square roots of 3 plus 21 times 5. That's going to be 105. Yeah. So that would be the surface area. Okay. Now, let's move on to cylinders. So here we've got a couple of cylinders. We've got a right circular cylinder here. Well, that's the only kind of cylinder we're dealing with at this point. So, but anyway, we've got a cylinder, and to get the cylinder, now remember, we're talking about surface area, the entire surface area. So we've got a base down here, which is a circle up here, and then we've got, of course, the surface, the lateral surface. Now, if we want to talk about the surface area in its entirety, we've got the area of the bases, pi r squared. Each one of them is pi r squared, this one and this one. But then we've got the surface area of this what's in between. So let me unravel that. So look, I've got this cylinder, and I'm going to kind of unroll. I'm going to unroll it or roll it out here. Okay. So here's the cylinder. Here's the lateral surface of that cylinder. Now notice it's got the height. But the question is, well, how long is this? How long is this thing? Well, remember the circumference of a circle is 2 pi r. So this length here is 2 pi r. So if we've got a rectangle here, and if we want to talk about the lateral area, it's going to be 2 pi RH. So the area in its entirety is going to be 2 times pi r squared, that's the top and the bottom, plus the lateral, 2 pi RH. Yeah. Now this is a right circular cylinder, which is the only one we've looked at so far. But here we go. Notice it's 2 times the base times the circumference times the height. Okay? 2 pi r squared, 2 pi RH right there. So if we wanted to get the surface area of this one, for example, we have 2 times pi times 3 squared. Okay? There's the area, and then we're doubling it. Plus 2 pi r, 2 pi times 3 times the height. And there you have it. So this is going to be 9 times 2, that's 18 pi, plus 24 pi. And let's see here, that's going to be 24, 34, 40, 42 pi, I believe. Yeah, there we go.